Recording.
So the incubescence was immediate.
Yeah.
If we don't have the APP, it is not. It takes some time.
To intimates.
Yes, because that one took a few seconds of flame exposure for the incubescence to happen in the first place.
It's like 2 minutes now.
Are you okay to go as long as it can
Yeah.
hold out? I suppose like SBR, this too will give at least 10 minutes. Although there's a bit of graphite dust flying about in this one.
Oh. Couldn't see.
I noticed specks flying about
Just specs.
slightly.
Right? If this is the base code, I think it should work really good, right? Because if this is PU based, then
Yeah.
the
I
top
mean,
can be any PU with any.
Yes. And the idea is that it's a self-cross-linking.
What do you mean by self-crossing?
That means you already have a cross-linking agent. So you just, it's a
okay.
water-based emulsion. So you just apply it on the surface and it will cross-link on its own.
Oh yeah, I saw something.
Yeah.
I think I saw a speck of graphite. It's 4 minutes.
eventually what we want to do is we want to put a thermocouple under this coating
Yeah, that would
between
be
at the interface.
That would be that concrete cube, right?
Yeah, I mean, or just simply,
You want to coat.
yeah, just log the temperature at the interface with time. Can that data logger do that?
Yeah.
I mean,
mean,
not the standard experiment. Just stick a
Oh,
thermocouple
okay.
between the coating and the.
Yeah, I think that is not a problem. Yeah. So just
So once you get an idea of
make
this,
the coat and make sure it stays there.
yeah, it stays. That's
Yeah.
actually the tricky bit, because when you first make these coatings, they're still quite fluid. How to keep the thermocouple there?
How long does it take to cure?
A few hours.
Just a few hours, right?
But then even then, it's still not so solid that if you probably leave the thermocouple, it will start tilting at the edge. I want to see how to make it adhere over there first. Because it's a pretty long wire, isn't it?
I think you can flatten the couple
You
first.
can do that, can't we?
Yeah, you can just keep.
So maybe sometime we'll do that.
Yeah, sure. Any time this week is good. Yeah. Then I can learn how to code the thing as well. So is this considered much better now?
Sorry.
I mean, is this system is considered much better than the SBR and the Expander?
I mean, we'll have to look at the temperature to be able to predict that. But in terms of flame retardancy itself,
Yeah.
it seems to be doing as well as the SBR, in fact. Eight minutes almost.
Yeah, 7:30 soon. Yeah.
You see, specks are flying about.
I saw a couple of specs
Yeah.
just now. Did that happen with the SBR coating?
No, no. Although we'll see what happens now because I've applied it in a slightly different way. Well, actually, even from that, it didn't happen. But then, there's one small difference. I used a slightly higher amount of EG for the PU
Oh, okay.
than for the SBR.
So it could be the
The amount.
number of the
Yeah.
formulations needs a bit of tweaking.
So because this one has 5%, that one has 3.58% EG. So this one has 15% APP, that one has only 10.5% APP. So the ratio of EG to APP should be kept 1:3.
1:3.
1:3. But the problem with SBR is you can't use more than 10-11% APP, otherwise it will turn counterproductive.
Yeah. There's always that optimal
Yes.
level, right? After
Yeah.
a certain amount.
With this one I thought I could go a little higher, and it seems to have been okay. Seems to have worked.
It's not that bad. It's not like everything is flying off.
Yes. Yes, last time it was a nightmare. I mean,
Oh,
flying all over the place,
Okay. really like burning something and you get all the ashes and stuff.
So it took 2 days to clean the furnace out.
It's 9 minutes 30 now.
Oh, good, good. So the EG itself seems to hold out in a 1,000-degree flame. Which is slightly
The
baffling,
Bunsen burner is 1000 degree.
approximately.
Yeah, because it's the blue flame.
Yeah.
We have reached 10 minutes.
Oh, good. We can probably go higher on this then. Let's hold it and see when actually it might start degrading.
How do you observe the degradation?
I mean, it will slowly start, the film will start
Catching fire.
vanishing. Because it's just burning, isn't it? It will just form carbon dioxide.
Ah, okay.
So the solid will slowly start going off. It's just that my hand should not go numb in the meantime. Well, we can live with that.
It's 11 minutes now.
With this amount of specs, we can live with that, I suppose, because anyway the advice always is cover your noses and mouths when you're leaving.
Oh no, to duck under,
Yeah.
yeah.
Preferably with a wet cloth.
Actually, it should be clear.
Or, if the material gives way, then the PU will start melting and trickling.
Okay. It's 12 minutes now.
I suppose this is one of the samples we could send for a cone calorimeter test.
Oh yeah. I'm interested to learn that as well. Yeah.
That might be a good idea because it seems to be holding out. I'm sure the parameters like peak heat release rate,
Yeah. I think
total
that is
heat
that is
release,
quite important.
they must all come down with this kind of behavior. And there is no smoke. That is interesting. There is absolutely no smoke. That is a point we will need to mention in the. When is the annual meeting?
It should be in January.
January. Okay. So we have some time
Yeah, we do.
to come up with some data, some more quantitative data.
Yeah.
Suppose Prof. Tan will be pleased to see this. He won't mind forwarding this for the cone calorimeter experiments.
It's 13 minutes now.
So from now on, it's just wait and watch. It has cleared 10 minutes, so it is matching the SBR performance. From now on, I'm just going to wait and watch and see how long it's going to take.
Actually, I can see a bit of smoke, but it's not like a black soot kind of smoke.
You do notice?
Yeah, I do notice. Partly in that direction,
Okay.
and it's not continuous, so like waves of. Yeah.
I suppose ultimately we will put it through the smoke meter.
Yeah.
We are getting a smoke tensiometer. Really, that's a pretty intense flame for a small patch of coating.
Yeah, I'm starting to feel some heat, but I'm not sure if it's your phone or or it's it from that. It's like 14 minutes.
And is it just me or is the char actually slowly intensifying now?
I don't know. Do you want to stop at 15 minutes and see?
You mean
Or
just
you
withdraw the
just
flame for
yeah
a
just
second?
keep going or
Yeah, I'll just keep going.
okay.
I'll just keep going. So long as integrity is there,
Because I haven't seen any specs since.
yeah. So long as material has integrity, I'm not particularly bothered. Mind you, the other problem is there is a draft. There's a draft going in as well. And I think the charge density is slowly increasing. I think we can live with that amount of specs.
Yeah, because I haven't seen any specs flying off. I think around 8 minutes after that.
Because you know, in a typical office fire, you'll have paper burning
Oh yeah.
for sure.
Yeah. Yeah, I think now the most important question is the temperature of the concrete. Or the temperature behind that,
Yeah,
that
at the
coating.
interface.
Yeah.
Yes. That is still under 60 degrees centigrade.
Oh,
Uh,
it's
the
not
reverse
hot
side.
to your hand.
If I can touch it, it is under 60. Probably more
Yeah,
like 40.
16 minutes now.
Yeah, more like 40. Just lukewarm, you know.
Yeah, you can see a bit of smoke.
Yes. Now you can actually. Now you can. I think that's the polyurethane going off.
Yeah, but there's no smell or anything.
That's probably because of the draft in the fume. But then, you know, the thing is, because of the nature of application, there is not much EG at the edges.
Okay.
It's mostly concentrated in a large
Yeah.
patch in the middle. So I would imagine that the ends will burn off faster. Temperature wise, 40,
Still good?
40. In 60 is when you just scan about, touch it. Beyond 60 you cannot touch it anymore.
Yep.
65.
It'll be burning
Yeah.
hot.
Nothing.
If this can go up to half an hour, I think it's a pretty pretty good for base coat.
Yeah.
And half an hour itself is
Yeah, we
already
can
one
try to,
level of fire
slightly
resistance.
tweak with the application
Yep.
and try to push for a patent.
Pattern. What do you mean a pattern?
For this sort of thing.
Oh, patent.
Yeah.
Oh, okay.
Because, you know, there are not many commercial coatings, FR coatings for concrete.
Actually, the point is, I think people haven't really seen the need to use it on concrete yet, and
But they assume that concrete should do its job by itself.
yeah, but not high strength or ultra high performance concrete. So those are
Oh, by the way, that when I was writing my report, I was reading that some of the findings on the WTC,
WTC.
the World Trade Center
Okay.
fire, and the Pentagon air crash,
Okay.
they came up with some interesting findings. They said that the actual fire that the temperature profile that the structures must have experienced is somewhere between ASTM E119 and 15 something, you know, that hydrocarbon.
Oh, hydrocarbon.
Yeah, there's a hydrocarbon fire test, isn't it? ASTM 15 something.
Okay. I think the hydrocarbon conditions could have been because of the
Flame.
fuel,
Yeah.
plain fuel,
Although,
and it's still not feeling hot.
now it is increasing.
Okay.
What's the temperature now?
It's about 1937.
20 minutes.
Yeah, 20 minutes in a
Now
while.
slightly warmer. Sense it.
Okay.
Yeah, maybe that might be a good idea.
20 minutes.
Fix the thermocouple on this side.
You can do both.
You can do both. isn't
Yeah,
it?
you can just
That might be more convenient.
find some way
Here
to
we
stick
have
it.
to find a way to. And I have a meeting with Arvind at 11:30 tomorrow.
Okay.
Maybe if you could come down, we could quickly just talk this over with him. Are you free
Okay.
around 11:30?
Yeah, sure.
So we'll just have a word with him. I mean, the problem is I don't know how to fix the thermocouple on this side.
Do you have a box of thermocouple?
Yeah, I've got them. I've got them now. So
Yeah,
I owe you 5. No, I owe you how many?
10.
15.
10. Yeah, just 10. Because I need to give it back to JC as well.
Yeah.
No, not really hot.
Increase. Again, no increase. Or just some temporary.
Seems like a very good chart.
Yeah. Because it is that side we are more bothered about, isn't it?
Actually, I read a paper and he mentioned that if you really want to go away from spalling, like the most effective measure is to keep your concrete under 100 degrees Celsius.
Under 100 degrees.
Yeah. But
Which side? I mean, even
I would say the
both, I mean, at least
interface or
the coating interface.
as in, because that wasn't on coatings, it was more for like concrete under spalling conditions. So and he just mentioned like the best way to keep spalling away is to have your concrete under 100 degrees Celsius.
But I would have thought that, this is not even reached 600, because if we get 600, we have observed formation of cracks of this concrete.
On this particular grade of concrete.
Because for the other coatings that we tried, for instance, when we tried ramping them,
600 is kind of the temperature where DCSH start to degrade.
Right.
So I think it could be, it's kind of like a dehydration kind of cracks, right? It's not really,
so we start observing cracks on the surface.
yeah, it's not really a spalling crack.
Yeah, and by the time, 800, it will start turning to powder.
Yeah, 800 is the structure, it's going off.
But this one has not degraded like the other ones.
Okay.
There is definitely that. This is not degraded like the other ones.
It's 22 minutes and 30 seconds already.
But then there is one difference. There we kept the slab in the furnace and heated it, so it is gathering heat from other sides as well.
Yeah.
So, no. Still, I would say at 60 on the outside. 60 on the outside, not more than that. How long has it been?
23.
Shall you take it to half an hour and stop?
Yeah. Because my hands are going numb.
Sorry.
No worries. But I think half an hour is already one fire rating by itself, 60 minutes. Or 30 minutes.
What temperature? There is some surface yellowing and browning on this side of the concrete.
Yeah, but it is
That
not
just
coated at all. Right?
Yeah, that could just be even from the polymer.
Oh, from the polymer.
Or okay, I mean, because the flame is leaking, that exposed part of the concrete will probably cause some changes. But the bulk itself seems fine. I could sleep on it.
So it's around 50, going to 60.
Yeah. No, not approaching 60, because 60, you will stop dipping your finger into it anymore.
Oh.
So I would say still 45, 50 on the outside.
How thick is the block? How thick is this?
This one is 5 centimeters.
So 50 mm.
That's a good indication, isn't it?
I think it's pretty promising. Because if it's going to be a two-system kind of thing, or even a multi-systems, and if this is a base coat, and if it's polyurea, typically any other polyurea flame retardants can stick onto it, right? And how thick is the coating again?
this one was when I didn't bother about the thickness. It's probably because it's even uneven.
1 mm, 2 mm, yeah, 1 2, right?
1 mm, 2 mm on the outside, 2 mm on the outside, not more than that. Because probably we don't need a very thick coating in that case.
Yeah.
But we don't need a very thick coating. The EG is doing a very good job. Doing a very good job. And the chart has held out. Yeah, 50 degrees. It's slowly increasing now. Now it is 60.
So it's starting to get hot. Yes, it's 26 minutes now. So
But it's still under 60. I mean, I can touch it happily. So we can have a thin, normal strength concrete layer and have this on top.
what do you mean by normal? I mean,
NSC, normal strength concrete.
yeah, for
On top of the HSC.
okay.
And then have this.
Oh, I don't think they will want to do that. If it's just high strength, the whole thing will be high strength. Because it's quite difficult to construct. You have to do the high strength first, and then after that you wait for it to dry, cure, and then you cast the normal strength, and you have to worry about the adhesion of these two concrete. It's 27 minutes.
Maybe it's still under 60. Still under 60.
Do you have those kind of thermometer that you can do an IR kind of? You know?
Have to see. We in the group don't,
Ah, okay.
but I don't know if the department, somebody might. We want to map the radiation with the temperature.
Ah, no, because you were touching it, right? So I was just thinking if you have one lying around, you can just do a scan.
Still 60, under 60. So this is working for at least 2 polymer systems now. SBR and polyurethane.
Okay.
Working for 2 of them now.
It's past 28 minutes already.
So now it is 60. If you're considering a relaxing bath or something, you would actually sleep on this side. It's the right temperature for that.
I think we should definitely show this during the meeting.
Sorry?
Show
I think so.
something like this
I think so,
during the
yes.
meeting, or
Yeah.
even this video without our audio. Mine's over.
Maybe a video, we just
Yes.
scroll forward and say
Yeah,
that
it's
this is
29
after
minutes
half an
now.
hour.
Or if time permits, we should do the thermocouple thing.
Thermocouple thing, yes. In fact, I want to do that in the next week and the week after that. So that we'll have some.
Because next week I'll be on leave.
Okay, right.
I'll be-
Yeah, okay.
So,
or
but
later
no,
than
we
that.
can.
I mean, if it's in January, then we still have some reaction time.
I will be back on the 28th, so anytime. Yeah,
So if you can just
we can just put the thermocouples and coat it before this Friday,
Yes.
and on Monday I'll be, because there's only 6 days that I can bring it over.
yeah, that should be all right. So that's right. I mean, let's put thermocouples on both sides. We'll talk
Yeah.
to Arvind tomorrow.
Yeah, sure. Okay, we are reaching the 30-minute mark soon.
Right.
Okay, half an hour.
Done?
Yeah, half an hour.